Hey, welcome back to Math with Patrick. Today's September 20th, and we're solving problem 263 from the Daily Epsilon calendar. And today is a intro to calculus, calculus 1 type of question right here. We're just finding the derivative of this function f of x is equal to some cubic, x cubed minus 9x squared plus 27x minus 27 times x squared minus 12. And we need to find the derivative of this function at x equals 4. So we're trying to solve for f prime of 4. And the answer today should be 20 because that matches today's date. So the normal thing, I guess the usual thing that we would do here to find the derivative of this is to use a product rule. We do have two things being multiplied. And after doing the product rule, or while doing the product rule rather, we would do a lot of power rules just because we have some kind of polynomial in both of these factors. Though I think it might be easier actually to rename this cubic right here. The only reason why I'm spotting it this quickly is because I did work on a problem a few days ago that had this exact cubic in it. I believe this is x minus 3 cubed. Now, if you want to fact check me on that, you totally can, just on your own time, because I'm pretty sure that these two things are equal. I just did it in a problem a few days ago. And the only reason why I'm doing this is because to me it would be a little bit easier to use the power rule and the chain rule to find the derivative of this factor instead of using the power rule 4 times. So just a preference thing. I didn't have to do it this way, but I felt like doing it. And then now once we find the derivative using the power rule, I always do the derivative of the first. So this is me using the power rule. I dropped the coefficient down front. I lowered the degree or the exponent by 1. Technically, I am using the chain rule as well here. I am finding the derivative of the inside part, but it is just 1, so I'm not going to write it. Okay, so I thought about my chain rule. I thought about my power rule. Back to thinking about the product rule right now. I'll take the derivative of the first times the second as is. Then I'll add the first times the derivative of the second. That's going to be 2x, and then minus nothing, actually, because the derivative of a constant is just 0. And I could expand all these things, but all we really need to know is what's the derivative of this function at x equals 4. So at this point, I could just plug in the 4 into all of my x's, and again, I should get 20 here. We get 3 times, and then 4 minus 3 is just 1, and 1 squared is just 1, so I'll do that, times something else. This is a 4 squared, so that is 16 minus 12 gives me 4. And then I'm going to add, this is another number 1, and it'll be 1 times, and then 2 times 4 is going to be 8. So from my product rule, I do get 12 plus 8, and that is equal to 20 today. Cool. And what this means, if we looked on a graph and we graphed this function, it would be some kind of degree 5 polynomial. So it'd be kind of wobbly, it would be 1, 2, 3, 4, 5, something like this. Maybe it'll look a little bit different, but I do know that somewhere along the way we are going to get some kind of value here. X is going to be equal to 4, and this 20 represents the kind of the instantaneous rate of change, or essentially just the slope of this function at x equals 4. So if you were to graph it, we would get a slope of 20 when x is 4, and that's kind of the meaning behind this number right here. So I think we're all done. Answer is 20, and I'll see you tomorrow. Bye.